Welcome dear students in today's lecture. Today we are going to discuss the methods of preparation of halogen derivatives of alkenes or haloalkenes, because in the chapter halogen derivatives now we have started preparation of mono haloalkenes, or in other words we can say haloalkenes or alkyl halides. The first method of preparation, which is from HX. Here HX means halo acids. This X is the general representation of chlorine, fluorine, bromine, iodide. Therefore, this HX might be HCl, HBr, HI, HF. And therefore, we are using this reagent to get our product monohaloalkanes. If our product is monohaloalkane, that means alkyl halide, then it is RX. Okay, and if we are treating something with this HX, then we have to logically think upon the expected reagent. What should be the reagent? Means what should be the compound which can react with this HX to give RX. And if we think in this way, we come to conclusion that ROH, that means alcohol, could be the better reagent which can react with HX, because it has that tendency to react with HX to form RX. And therefore the substrate or the main compound on which this substitution is going to happen means its functional group OH is being substituted by X here in this case. For example, consider haloacids dissociate into H plus and X minus. Then in this case, this OH minus is going to be replaced by this X minus to convert RX, and the side product, when this OH minus would be displaced from this, that will combine with this H plus to form a side product, water. And here you have been able to, or we have been able to write the balanced reaction, general reaction of formation of alkyl halide from alcohol, or here alcohols are converted into alkyl halides by treating with HX. But now we have to think about the different possibilities of HX. What are the different possibilities of HX? As I have told you in last lecture that don't think about fluoride, because fluorides are not easy or safe to handle, so that we would not talk about HF. And we will always think, whenever there is HX, we will always think about HCl, HBr and HI. So that our three possibilities are HCl, means as HX we can take HCl, as HX we can take HBr, as HX we can take HI. And then our need is to think about what could be the possibility of reaction of HX with ROH. So that what could be the possibility of reaction of HCl with ROH. So that here I have taken ROH, and the first possible HX is HCl, and what would be the RX? Here in this specific case, RX would be RCl, and the side product would be H plus OH minus H2O. So this would give us alkyl chlorides. But think about this HCl reactivity, or think about this ROH reactivity also. In all those cases, ROH, if ROH is tertiary, then it is highly reactive. If ROH is secondary, it is less reactive. If ROH is primary, it is very less reactive. Think that this reacts faster, tertiary alcohols react faster, secondary less faster, and primary reacts slowly. So this is about the primary, secondary and tertiary nature of alcohol. But what about the reaction of HCl with this ROH? This is not a simple straightforward reaction as shown here. Here we need one catalyst or one reagent, and that is known as zinc chloride. And this zinc chloride should be very dry. In your textbook, it has written that it should be anhydrous, means there should be no part of water in that, and therefore you have to consider this mixture, means this HCl does not react directly with ROH. To make ROH more susceptible to reaction or more favorable to reaction, then it has to be treated with this zinc chloride, which should be dry, and then that ROH becomes more favorable to react with HCl. Therefore, this mixture of HCl and zinc chloride is known as Lucas reagent. And this process of conversion of alcohol into alkyl chlorides by treating them with the mixture of HCl and zinc chloride, that process is known as Grove's process. And now here our reaction is complete. We would need some heat also here in this case, and here our reaction is general representation of reaction here has completed. It means alcohol has treated with HCl in presence of dry zinc chloride, anhydrous zinc chloride. It has given us alkyl chloride and side product H2O. Let us think about the specific reaction. I would just replace this R by any alkyl group. The first and smaller alkyl group is methyl. So let me just write methyl here, CH3, and then I would attach this OH to CH3. So this alcohol is now specific alcohol, and the name of this alcohol is methyl alcohol. And now this alcohol would be treated with this HCl in presence of zinc chloride, which is in a dry or in anhydrous form, and then that methyl alcohol will be converted into here H plus Cl minus. This Cl minus would replace this OH minus, and this compound would be the CH3Cl, the product. Probable product would be CH3Cl, and this H plus will combine with this OH in this way, and it will give H2O. So our product is chloromethane, or in common name we can say that methyl chloride. Here in IUPAC system, methyl alcohol is named as methanol, and methyl chloride is named as chloromethane. So this is the method of conversion of alcohol into alkyl chlorides. Now we'll think about what if this chloride is replaced by bromide, means as an HX. Now we are thinking about the second possibility of HBr. It is the same reagent which is to be used here, same catalyst or same mixture is to be used here? No. Here there are some facts which are to be considered. First fact is that this HBr is not stable, has to be prepared in situ. At that situation, that has to be prepared in the same container where you are treating with this alcohol, and therefore here bromide or hydrogen bromide or HBr, that is not being taken in a ready-made form. It is prepared by using the mixture of NaBr, that means sodium bromide, plus H2SO4, and this would be possible if the percentage of HBr is 48. Here we have been able to write the next reaction of alcohol with HBr. In this reaction, so as to get HBr, we have to treat the mixture of sodium bromide and sulfuric acid, because this mixture would give us HBr. How does this give us HBr? Let's think about that reaction also. Here I would write this reaction, NaBr, sodium bromide plus sulfuric acid. As you know that Na plus, the dissociation of sodium bromide, Na plus Br minus, and dissociation of H plus, twice of H plus and SO4 minus minus. In this case, 2H plus are to be coming out from this H2SO4. We need 2Br minus to combine and to form this into HBr. Therefore, this would give us 2 molecules of NaBr. When react with 2 molecules of H2SO4, this would give us 2 molecules of HBr, plus the side product salt would be twice of Na plus SO4 minus. It will be twice of it would be Na2 SO4, sodium sulfate. Na2 means twice of Na plus SO4 minus minus. So that this mixture of NaBr, sodium bromide and sulfuric acid react with each other, NaBr plus sulfuric acid, and that gives us HBr, twice of HBr and Na2SO4, and that will combine with HBr. And here now, if we are treating Br, we have to replace this chloride by Br, and we will get RBr, means alkyl bromide. In the same example which we have discussed about HCl, here we have to replace all those reactants with this case, specific case. We have to take HBr, and on the arrow we have to write mixture NaBr plus H2SO4 and heating. Here we get Br substituted at the place of OH, and here instead of HCl we have to write Br, and this would be not methyl chloride, but this would be methyl bromide. मग हे काय असेल, मिथिलचं काय असेल तुमच्या, this would be methyl bromide. In this way we have been able to convert this alcohol into alkyl bromide. Then third possibility of HI. So what if you just have to replace this bromide by iodide? I will just replace this bromide with iodide. If it is H plus I minus, then how does this comes? How does this comes? This will come from the mixture of NaI again, and means again sodium salt. Like we have taken sodium bromide, that was also the sodium salt. Therefore, I used word again. So NaI, and here the acid is not H2SO4, but this is phosphoric acid, and its formula is H3PO4. And this mixture would react in the same manner to give like this, to give us HI. And here 95% HI or 95% concentration is required to convert this alcohol into alkyl iodide. Now we will replace this Br, and we will write here I, and here also we will replace all those reagents which are used in previous reaction. Now this would be H plus I minus, and this HI will come from NaI plus H3PO3. In this way you will get iodide. This is iodomethane or methyl iodide. What is the name of this compound? This compound is methyl iodide. In this way, by using haloacids, we have been able to convert these alcohols into respective alkyl chlorides, alkyl bromides, alkyl iodides. So these are the three reagents, three haloacids, and there are three different conditions to react with alcohol and to convert into alkyl halide. And let's to summarize these three reagents. First reagent which reacts with alcohol is HCl. It gives alkyl chloride, and the condition is it has to be treated with zinc chloride. That means the mixture of HCl and ZnCl2, dry ZnCl2, has to be treated. That is known as Lucas reagent, and the process is known as Gru's process. The second reagent is HBr, which has to be taken 48%, and that comes from mixture of sodium bromide and sulfuric acid. And third reagent is HI, which also comes from the mixture of sodium iodide and phosphoric acid, and 95% of that HI is required to convert that alcohol into alkyl iodide. And in this way, as like we have taken one example of conversion of methyl alcohol into corresponding methyl chloride, methyl bromide and methyl iodide by using three different mixtures. In the same manner, your homework is to convert methyl alcohol, ethyl alcohol, N-propyl alcohol, isopropyl alcohol, sec-butyl alcohol, or you can say that propan 1-ol, propan 2-ol, butan 1-ol, butan 2-ol, ethanol, so on. So those alcohols you can try to convert them into alkyl halides by using these three haloacids and their corresponding mixtures. Thank you.